Hello, everyone. Welcome to Astrologer Climate Witness tonight. I am going to be covering something that's very heavy. So if certain people would like to not watch, I'm giving a warning now that what I'm going to be reading is not easy to digest. So you might want to not watch if you have a lot of sensitivity to all of this material. Then I'm going to move on from there and discuss ecological scientific aspects of evolution. That'll be not that long because this article is kind of long for what I'm reading, but I did want to cover that. So those things will be coming out of the book Overshoot by William Catton. But this article that I'm going to read is it's a projection into the future, but it is based on real scientific evidence. It is basically what is going to be happening because all of the hype we hear about reducing emissions is going nowhere. I mean, the hype is, but the reality of reducing emissions, not going to happen. So what we must come to terms with is a reality. And that's not easy. So again, if you really don't want to hear this, I would suggest you not watch. But if you're tough enough, I hate to put it that way, but if you really want to know, then you can go ahead and listen. And now, one of the reasons I'm covering all of these things, again, is because we can use astrology to frame much of what we're doing, what's going on the planet, what we've done to this planet. We can use astrology to frame that. And as others who don't study astrology might be listening, that's what astrology can do. It's more or less a correlation. It's a mirror as to our behavior. There's no evidence that there's any cause and effect, but the correlation is there. Over thousands of years, it's been studied. So the Pluto in Aquarius, which I'm really into discussing, brings to me the thoughts that, as I've mentioned before, humanity is represented by the sign Aquarius. And with Pluto, the concept of death, rebirth, and transformation is in that sign. But you have to look at the reality of what we've done. It's just like any other situation in a natal chart. If someone's looking at their chart and wanting to know what is going to happen with a particular transit, heavy transit, you have to look at the foundation of your behavior before that. It's not going to miraculously turn out the way you want if the foundation that you've laid, this is kind of depressing, but the foundation you've laid can't lead to the positive. You must go through the negative and the pain. And you know that saying, if it doesn't kill you, it makes you stronger? Well, sometimes it does kill you. Like I said, you better get out of here if you don't want to watch this or listen. So anyway, here goes. I'm going to read this. This is her author name is Sarah Connor. It's Collapse 2050 is her site, and it is Substack. I think she's on, maybe other places. Okay, here we go. This lighting is terrible, I know. I worked on it, but 2030 Doomsday Scenario, the Great Nuclear Collapse. A timeline of the endgame for human civilization. Humanity was constructed, well, let me start again. Humanity has constructed a doomsday dead man switch that threatens civilization. Climate destruction will make it increasingly difficult to avoid the looming global nuclear catastrophe we've created. So, let me pull this a little closer. That might help a little bit. I hate the fact that the computer is reflected in my glasses, but oh well. So, if you haven't left yet and you don't want to listen, you better leave now. Here's how our future might unravel. Okay? The late 2020s, climate red alert and infrastructure strain. By the late 2020s, Earth's climate is in unprecedented turmoil. Global average temperatures are consistently 1.5 C above pre-industrial levels. Each year brings record-breaking heat waves, freak floods, and droughts that batter infrastructure. That's key. Batters infrastructure. Now, what people don't seem to understand, who don't study climate change and don't grasp the science, they don't grasp that it's the infrastructure, losing that, meaning transportation systems, electricity, our food supply systems. Those are the things that are going to be breaking down. That will be what does us in. It's not that everybody's going to die of a flood all at once, or everybody's going to die of, storms. I think that's a lot of what people think, that it's those weather catastrophes that will kill us all off. But that's not exactly, it's more indirect than that, of course. Yeah, I'm lifting this up a little bit. Okay. There. That might be a little better. So just to be clear, those are the things that we will experience and that will cause our not able to live our lives. Okay? Coastal cities flood more frequently, roads buckle in extreme heat, and power grids strain under surging demand for cooling. The cascade of climate disasters sets the stage for systematic collapse. As societies grapple with runaway warming, the resilience of critical infrastructure, power, water, transit erodes. Energy systems enter a crisis even before 2030. Nuclear power, which in 2025 still provided about 9% of the world's electricity from 440 reactors, becomes increasingly unreliable. Many nuclear plants struggle with climate stresses. Cooling water sources heat up in the summer, forcing reactors to reduce output or shut down to avoid unsafe temperatures. For example, a 2028 European heat wave pushes river and sea temperatures above 25 C, triggering emergency shutdowns at multiple reactors that cannot be cooled effectively. At the same time, stronger storms and floods threaten reactor safety. Dozens of reactors worldwide are unprepared for extreme flooding, meaning a dam failure or storm surge could lead to a Fukushima-scale accident. Worrisome reports emerge of power plants in floodplains and coasts where defenses are overtopped by rising seas and torrential rains. By 2029, global carbon output remains high, and natural feedback loops are kicking in. In the Arctic, permafrost thaws and releases methane, creating a vicious warming cycle where initial warming triggers more emissions, leading to even more warming. Scientists caution that a tipping point is near, beyond which climate change becomes self-perpetuating a true runaway scenario. Society approaches 2030 in a precarious state, aware of looming catastrophe, yet unprepared for its speed. The stage is set for the coming collapse, with power grids and nuclear facilities, the backbone of the industrial world, already under severe strain. Early 2030s. Blackouts and the first reactor crisis. 2030 marks the breaking point. A confluence of climate catastrophes collapses power grids across multiple continents. A severe global heat wave in the summer of 2030 brings record electricity demand, while many power plants, nuclear and coal alike, are derated or offline due to overheating coolant water. The then powerful Category 5 storms strike in succession. One hurricane inundates the U.S. eastern seaboard, while an unprecedented typhoon swamps Southeast Asia. These disasters knock out transmission lines and flood key substations, leading to prolonged blackouts in dozens of major cities. Emergency systems are overwhelmed. With communications down and transportation paralyzed, manpower shortages become acute. Many operators and engineers cannot reach their stations. Nuclear power plants are among the first to feel the emergency. Grid failure triggers automatic reactor scrams, rapid shutdowns, that's what that is, at plants from Florida to France. Control rods halt the fission reactors, but decay heat in reactor cores still needs cooling for days to prevent meltdown. Normally, backup diesel generators would power the cooling pumps, but the scale of the blackout means diesel resupply is uncertain, and some generators fail in flooded facilities. In a grim reflection of 2011's Fukushima disaster, several coastal reactors lose all power as storm surges drown their backup generators. Within hours to days, the first meltdowns occur. In 2031, a reactor in South Asia becomes a flashpoint. Its cooling pumps falter after the grid collapse, leading to the core to overheat. The reactor's heart melts through the containment in a matter of days, releasing a plume of radioactive steam and debris. Nearby, an even greater danger unfolds. The plant's spent fuel rod pool, an even greater danger, packed with years of highly radioactive spent rods, boils dry without cooling. Exposed to air, the zirconium cladding of the fuel ignites, triggering a fire that belches long-lived radioactive isotopes directly into the atmosphere. This nightmare scenario, once narrowly avoided at Fukushima by heroic ad hoc measures, now plays out in full. Local and regional consequences are immediate and harrowing. Authorities, already struggling with disaster response, hastily order mass evacuations around stricken plants. In the South Asia incident, a radius of 30 kilometers is declared a no-go zone as radiation levels spike. Over 1 million people are displaced in this region alone, fleeing what swiftly becomes a nuclear dead zone. Many receive significant radiation doses during the chaotic evacuation, trapped by traffic jams under drifting fallout. Comparisons are made to Chernobyl in 1986 evacuation. There, 130,000 people were permanently resettled in a 1,000 square mile exclusion zone established. But the 2031 event affects an even larger population in a densely settled area. Nearby, countries track the radioactive cloud as it crosses borders. Within days, radioactive iodine and cesium are detected in cities hundreds of kilometers downwind. Governments distribute iodine tablets to help block uptake of radioactive iodine in thyroid glands, recalling measures taken after Chernobyl and Fukushima. Farmers in downwind regions watch in despair as cesium-137 contaminates soil and crops, knowing from past accidents that those lands may be unsafe for farming for decades. After Chernobyl, for instance, cesium lingering in the soils kept pastures in part of Europe under restriction for 20 years. Globally, these first reactor crises send a chilling signal. Airborne radiation from the fires and vented steam reaches the upper atmosphere and begins circling the planet. Within weeks, trace amounts of cesium-137 and strontium-90 are found in faraway monitoring stations. While the initial fallout poses the greatest danger locally, the global dispersion of radionuclides raises alarms. Public health experts warn that even low-dose fallout on crops could, when multiplied across the world, elevate cancer risks and contaminate food supplies. International markets are rocked as nations ban produce and grain imported from entire regions. The economic shocks compounds the physical destruction. Already destabilized by climate disasters, the global food supply further fractures under fear of radiation in goods. Perhaps most critical for what comes next, these early accidents erode the capacity to respond to future crises. Emergency workers who heroically battled the first meltdowns, hosing overheated reactors attempting improvised cooling, have suffered radiation exposure or exhaustion. Large swaths of power grid remain offline, making rolling blackouts the new normal even in areas not directly hit by climate events. This energy shortage slows recovery efforts and undermines the cooling and monitoring systems at other nuclear sites. By 2032, the world faces a stark reality. Roughly 10% of the nuclear reactors worldwide are in some stage of crisis, either already melted down or scramming and struggling to keep their hot cores and spent fuels safe. What was once unthinkable now seems inevitable. So, mid-30s, cascading meltdowns across the world. As 2035 approaches, the situation spirals into a cascade of nuclear calamities. Ongoing climate chaos keeps hammering human systems. After year, megastorms, wildfires, and heat waves pummel regions before they can recover. The compounded infrastructure damage means many areas have only intermittent electricity and scarce supplies. In this environment, about half of the world's nuclear reactors are effectively left unattended or unserviceable. Some due to direct disaster impacts, others because manpower and resources have collapsed in the region. Governments in relatively stable areas attempt to initiate orderly shutdowns of reactors as a preventative measure, but even a shut reactor needs years of active cooling and oversight. In many cases, those best efforts falter. By 2030-2035, a wave of reactor meltdowns unfolds on nearly every continent. It takes at least 20 to 40 years, 20 to 30, 30 to 40, to decommission a power plant so that it's basically safe. But then you've still always got the waste in the dry caskets. If you manage to undo the spent fuel rod pools without disaster, even if they clink together. That's what they were trying not to have happen in Fukushima. So, yeah. And they had to use this massive robotic crane in order to move these huge spent fuel rods without clicking them together so that they explode into fire. The numbers are staggering. What started with a few isolated accidents in 2030-2032 explodes into dozens of sites in crisis. Older nuclear stations prove especially vulnerable. Lacking passive cooling features, they succumb quickly when grid power and backups fail. Newer reactors, touted as meltdown-proof, also face unforeseen challenges. Coolant reservoir tanks run dry when maintenance crews vanish, or hydrogen explosions like those that blew apart Fukushima's reactor buildings occur due to unvented pressure. Spent fuel pool fires add to the nightmare at many sites. Analysts later estimate that these pool fires released even more radiation than the reactor core meltdowns in several cases. Since pools often contained decades of fuel assemblies, holding up to 10 times the long-lived radioactivity of a reactor core in the pool. Each collapsing plant creates its own radiation footprint. By the mid-2030s, a patchwork of radioactive exclusion zones scars the northern hemisphere. In Eurasia, multiple zones from Western Europe through Russia, South Asia, and East Asia dot the map where reactors have failed. Some of these zones begin to overlap, forming a virtually continuous swath of contaminated land in parts of Europe and Asia. In Western Europe, for example, meltdowns at 2 French reactors and 1 German reactor in 2034 forced evacuations that cover large parts of the Rhine Valley. Later, a catastrophe at Ukraine's Zaporizhzhia plant, I've heard it, but I forget, already endangered for years prior, adds to the chain, rendering areas along the Dnieper River highly radioactive once before. We've been hearing those names. I forgot how to pronounce them. North America is not spared. A meltdown at an aging Midwest U.S. plant sends radiation across several states. Canada's Ontario reactors, shut down due to power loss, suffer a fuel pool fire that spreads contamination through the Great Lakes region. In total, roughly 50% of the world's 400-plus reactors are now either destroyed or abandoned. Humanity suddenly finds itself living with hundreds of Chernobyl-sized disasters at once. Local and regional consequence, so you're not going to be running around making cement domes over those like they did with Chernobyl. They had people, they had the materials, they had the power, the fuel to do one dome. This is a little different. Local and regional consequences reach an apocalyptic scale. Hundreds of millions of people become actual or potential refugees from high radiation areas. Major cities near failed plants are emptied. By 2035, regions like the French Riviera, the North China Plain, and the U.S. eastern seaboard have pockets that resemble Pripyat, ghost cities left to wild animals. Pripyat. I think it's Pripyat. The contamination of land and water is immense. Isotopes like cesium-137 and strontium-90, you don't want to get strontium-90 in you. It takes one particle. I can't remember if it's an atom or, I don't know. And it's so radioactive, you got cancer. Forget it. Oh, it's around now from the bombs that have already been exploded. Yeah, it's around. It's in the atmosphere. Let me say that again. The contamination of land and water is immense. Isotopes like cesium-137 and strontium-90 settle into agricultural soils. Just as Chernobyl's fallout once contaminated 200,000 square kilometers of east of Europe to some degree, the 2030s meltdowns contaminate vast expanses of the globe. Agricultural experts estimate that a significant fraction of the world's breadbaskets are now tainted by radioactive fallout. For example, the Punjab region and the American Midwest both see cesium levels in soil far above safe farming limits, threatening global grain supplies. In many countries, the choice is stark: eat potentially contaminated food or starve. Livestock that graze on fallout blanketed pastures accumulate radionuclides in their meat and milk. As British sheep did for decades after Chernobyl, governments impose strict bans on food exports from these zones, and global food prices skyrocket. Famine looms for countries that relied on imports from now irradiated farmlands. Beyond human habitation, ecosystems suffer radiological damage layered on top of climate stress. Forests downwind of reactor accidents turn brown and silent as foliage and wildlife absorb heavy doses of radiation. In some intensely contaminated zones, an eerie calm prevails, reminiscent of how the core area around Chernobyl became an accidental wildlife refuge, but one where many organisms die young or show mutations. Initially, high radiation kills or stunts many plants and animals. Forests die and animal populations plummet. Over the later 2030s, some wildlife returns to abandoned zones, benefiting from the lack of humans. However, in areas of high contamination, biodiversity remains low and animals show signs of chronic radiation exposure. The web of life in poisoned radioactive cesium, and strontium work their way up food chains, affecting predators and prey alike. Combined with the ongoing climate upheavals, heat stress, wildfires, habitat shifts, the added burden of radiation pushes many species to extinction in contaminated regions. Aquatic ecosystems are also hit. Radioactive runoff flows into rivers and seas, causing fish kills and long-term mutations in the fish reproductive cycles. The global consequences of this mid-2030s nuclear cascade are profound. Atmospheric circulation transports radioactive pollution around the world. By 2035 and 2036, background radiation levels have risen noticeably above 2020's norms in both hemispheres. Radioactive particles from multiple meltdowns are detected in the Arctic and even in the Antarctic, having been carried by air currents. Although concentrations far from accident sites are low, no corner of the planet is truly untouched. In the northern hemisphere, intermittent waves of fallout descend whenever rain clouds scavenge particles from the upper atmosphere, a phenomenon similar to the fallout patterns observed after nuclear weapons tests and Chernobyl, but now sustained by ongoing reactor fires, and spent fuel blazes. Public health experts warn that long-term cancer rates will climb worldwide. Every additional becquerel, I've read that 100 times, becquerel in our food and water increases risk. By the late 2030s, the world's socioeconomic order has largely disintegrated. The combination of climate catastrophe and the radioactive contamination fractures the globalized economy. International travel is nearly non-existent, both because of infrastructure breakdown and fear of radiation exposure on long journeys. Trade in food and goods has devolved into ad hoc local barter, since centralized distribution is impossible under constant disaster. Regions that remain habitable from safe zones, relatively less contaminated with tolerable climate, mostly in the far south hemisphere, like under New Zealand, and a few remote northern areas, for instance, parts of New Zealand, Patagonia, Siberia, far from any meltdown sites and somewhat buffered by distance, become refuge for those able to relocate. Even so, these areas face their own challenges from extreme weather and inflows of refugees. Humanity's population shrinks precipitously due to famine, conflict, radiation-related illness. What was roughly 8 billion people in the 2020s falls by at least hundreds of millions, for more likely billions by 2040. Those losses stem not only from immediate disaster casualties, but also from secondary effects: hunger, lack of medical care, and weakened immune systems in a ravaged environment. 2040s, the toxic legacy settles in. By the 2040s, the frantic pace of new catastrophes slows somewhat, not because the crisis is solved, but because so much has already collapsed. Most of the vulnerable nuclear reactors have already broken down by this point or were preemptively shut. The ones that survive the 2030s are primarily in regions that remain functional enough to manage a safe cold shutdown or have newer designs with passive cooling. However, the world now faces the long aftermath of what has happened. The 2040s are a bleak decade of enduring fallout, literal and figurative, where humanity grapples with the toxic legacy of hundreds of reactor failures amid a climate that remains hostile. One grim reality sets in. The radioactive contamination is far from a short-term problem. Many of the isotopes released have half-lives measured in decades or longer, meaning the radiation will persist for generations. For example, cesium-137 half-life is 30 years, and strontium-90 half-life is 29 years. Remain abundant in the soils of meltdown zones and downwind regions. These isotopes mimic vital nutrients. Cesium behaves like potassium, strontium like calcium. So they continuously cycle through the plants, animals, and water. That's why if you get strontium-90 in you, you get bone cancer. Crops grown in contaminated soil uptake cesium. Grazing animals contaminate it in their flesh. Humans who consume those foods further concentrate it in their bodies. In the 2040s, scientists document how radioactivity has infiltrated the global food chain. Traces of cesium-137 show up in grain and milk, even in safe zones, due to minute fallout that has spread worldwide. In harder hit areas, food contamination remains a severe obstacle to resuming agriculture. Even when farmers attempt to cultivate, their produce often exceeds safety limits imposed in the old world. Consequently, hunger continues to stalk populations. Arable land might be available, but not all of it can be used without slowly poisoning those who eat from it. Another challenge is the management of radioactive waste and materials. The reactor meltdowns, and fires have dispersed a lot of radioactivity inventory into the environment, but significant amounts still reside in the wreckage of power plants. Spent fuel rods that did not burn sit in cracked pools or dry casks at sites now too hazardous for people to approach. The reactors themselves hold tons of uranium and plutonium in their ruined cores. In the 2040s, these wreckage sites are largely uncontained. Unlike Chernobyl, where a concrete sarcophagus was built over the destroyed reactor, many 2030 accident sites have been simply abandoned mid-disaster. Some have rubble or sand piled by drones or remote machines to try to smother fires, but no comprehensive containment. This means groundwater leaching becomes a major concern. Rain percolating through the wreckage reactors carries radioactive contaminants into aquifers and rivers. For communities downstream, if any remain, water sources are compromised. In coastal plants, continued leakage of radiation into the ocean is observed. By 2045, marine biologists report increased contamination in sea life far from any direct fallout, indicating that ocean currents have spread the pollutants. Strontium-90, for instance, known to accumulate in fish bones, is found in fish thousands of kilometers from any reactor site. The Pacific Ocean, already contaminated by the Fukushima accident in 2011, now receives orders of magnitude more radionuclides from multiple Pacific Rim reactor failures. Ocean fisheries, already stressed by climate-driven acidification and overfishing, are now additionally burdened by radioactive pollution. Many fishing zones are closed due to cesium levels, pushing more coastal communities into protein scarcity. The climate crisis continues unabated in the 2040s, though its character has changed. With industrial civilization greatly diminished, by mid-decade, greenhouse gases from human sources have plummeted. Oil consumption is a fraction of what it was, and many coal plants are offline, some destroyed, some simply without supply lines. This initially gives a glimmer of hope that anthropogenic warming might slow. Indeed, by the late 2040s, some climatologists note a slight destabilization in CO2 levels. However, the damage is already done in terms of triggering feedback loops. Warming continues due to inertia and feedback emissions like methane from permafrost. By the 2040s, the world breached 2C, likely more like 3, warming, and by 2050, it may be heading toward 2.5C, quite possibly approaching 4.5, despite the collapse in human emissions, because it's coming out of the earth now. The ongoing extreme weather further complicates the radioactive legacy. For example, wildfires in contaminated forests have become a recurring nightmare. Each summer in the 2040s, large wildfires ignite in areas with dry hot zones. Some of those areas include the evacuated zones dense with dead trees and dry brush around former reactor sites. When these fires rage through the radioactive forest, they loft radionuclide-laden smoke into the sky. In 2043, a massive fire in the abandoned part of the Eastern Europe, fueled by a drought and heat wave, burned hundreds of thousands of acres, remobilizing cesium and plutonium deposited in the soil. Soot and ash carrying these pest particles travel far. Monitors as far away as northern Scandinavia register spikes in airborne radiation. What was effectively locked in the soil is thus released anew by fire. a horrific feedback where climate-induced fire boosts the spread of nuclear contaminants. Similarly, intense storms cause flooding and dust storms that redistribute radioactive sediments. Rivers that flow through meltdown zones periodically flood and deposit radioactive silt onto downstream plains. The environmental contamination, therefore, is not a static situation. It worsens in pulses whenever climate disasters strike the polluted zones, creating secondary fallout events throughout the 2040s. Human society in this decade adapts in grudging, hard-scrapple ways. In relatively uncontaminated regions, people develop new habits to minimize radiation exposure. For example, rooftop farming and hydroponics indoors become crucial to grow food in controlled environments to avoid contaminated soil. Water is filtered through improvised means, layers of charcoals and resins to trap radioactive isotopes. People often wear personal dust dosimeters and masks when venturing outside, especially on windy days that could carry dust. The specter of radiation sickness and cancer is a constant part of life. Medical knowledge from past nuclear accidents is applied wherever possible. For instance, Prussian blue pills, which bind radioactive cesium in the digestive tract, are prized treatments to reduce cesium uptake. Potassium iodide pills are stocked to predose the thyroid in case of new radioactive iodine releases. However, these medications are in short supply as global production capacity and supply chain infrastructure is decimated. Despite these measures, the health toll is severe. Cases of cancer, thyroid, leukemias, solid tumors skyrocket, and with healthcare systems devastated, many go untreated. There is also a rise in birth defects in regions that were exposed to high radiation during the 2030s, a tragic echo of what was observed in some areas after Chernobyl, now magnified by wider scale. Mental health is another casualty. Whole generations grow up under the dual shadow of climate apocalypse and invisible radiation hazard, leading to widespread psychological trauma and eco-radiation anxiety. By the end of the 2040s, some stabilization occurs in the sense that no new major nuclear disasters are unfolding, simply because so few reactors remain operational or intact. What remains of organized governments and international institutions focuses on containment and mitigation. There are projects, for instance, to entomb certain high-risk reactor sites in concrete, as was done with Chernobyl, now that radiation levels around them have decayed enough to allow heavy machinery to approach for short periods. One such international effort in 2048 finally encases the remains of a major U.S. reactor that melted down 15 years prior, using robotic builders to minimize human exposure. These efforts are slow and cover only the worst offenders, but they at least aim to prevent further leakage. And in decades to come, it'll need to be done again, because that's what happened with Chernobyl. The dome that was put over that, that happened in 86, I think, 86, I can't remember, but I think it was 86. The dome was leaking radiation and getting worse, so they had to put another cement dome over it. 2050s and beyond, a transformed and radioactive world. Earth is a fundamentally altered planet. Human civilization has been gutted. What remains is a patchwork of survivor communities and a few stable enclaves attempting to rebuild amid the ruins. The climate is hotter. Seas are higher. Seasons are unreliable. That's what climate change is. No more recognizable seasons. On top of this, the planet's surface carries the wounds of nuclear collapse. Even as some dangers gradually subside with time, others will persist for centuries. Radioactive decay has slightly improved conditions in the decades since the meltdowns. By 2060, it will have been 25 to 30 years since the peak of the disaster. Isotopes like iodine-31, which caused acute thyroid exposures in 2030s, are long gone. With an 8-day half-life, they decayed away within months of release. The most intense short-term radiation from the accidents, which came from these short-lived fission products, has thus faded. Even some medium-lived isotopes like cesium-137, and strontium-90 have been about 1/2 life pass. Areas that were extremely contaminated by cesium in the 2035 might register roughly half the cesium levels by 2065, simply due to radioactive decay, not counting redistribution. This means that radiation levels in some exclusion zones are lower in 2060 than they were in 2040, potentially allowing limited access with protective gear. In a few zones on the periphery of disasters, radiation has decayed enough that authorities consider letting people return with precautions, much like parts of Fukushima exclusion zone were gradually reopened after a decade. Wildlife begins to reclaim many regions more fully as human absence continues. In moderately contaminated areas, animals have multiplied, albeit some with shorter lifespans or health effects. The paradox seen in Chernobyl's exclusion zone, where wildlife thrives despite radiation because human pressures are removed, is now playing out on a larger scale. Some scientists in the 2050s cautiously talk of certain abandoned areas becoming de facto wildlife reserves, albeit radioactive ones. However, other hazards will essentially be permanent on human timescales, meaning all through human generations. One is plutonium. Many reactor explosions and fires spread particles of plutonium-239, an alpha-emitting isotope with a half-life of 24,000 years, into the environment. These particles are extremely dangerous if inhaled or ingested, as they can lodge in the lungs or bones and irradiate tissue for a lifetime. Plutonium is heavy and tends to deposit near accident sites, but fires and smoke did carry some of it regionally. This means certain hotspots within, say, a few kilometers of the worst meltdowns will remain lethally radioactive essentially forever, as far as human planning is concerned. Even after cesium decays, these areas will be unsafe to inhabit without serious cleanup removals of topsoil. Another enduring issue is the spent fuel and waste that remain. By 2070, the fuel assemblies that did not burn up in fires have cooled radiologically, their short-lived fission products gone, but they are still highly radioactive and contain long-lived isotopes. Ideally, they would be secured in geologic repositories to isolate them from the biosphere, but with the collapse of industry capacity, most of this waste is simply sitting wherever it was last stored. Some in dry cask containers that can last a few decades. By the 2070s, those casks may be deteriorating, potentially releasing their contents if not maintained. Thus, the world faces a slow seepage of radionuclides for centuries. The habitability of the planet is dramatically reduced compared to pre-2030. Large regions are effectively off-limit due to radiation, essentially parts of the mid-latitude North America, Europe, and Asia, where population was once highest. The tropics, meanwhile, suffer extreme heat and humidity, thus push human heat tolerance to the limit. In some equatorial zones, regularly see wet bulb temperatures above 35°C, unsurvivable without AC, and there's not really going to be any AC. The safe zones by the 2050s are those rare places with combination of tolerable climate and minimal fallout. These tend to be in the southern hemisphere or isolated islands, portions of South America, southern cone, and Africa, extreme south or highlands in East Africa. See clusters of survivors who have organized small agrarian societies, carefully selecting crops and livestock that can grow in changing conditions and relatively uncontaminated soils. Australia and New Zealand, which had no nuclear plants of their own and were distant from most fallout, become crucial harborages of technological memory. Although Australia's interior is severely hit by heat and drought, its southern coast remain livable. Antarctica and the Arctic islands, free of radiation but harsh in climate, see some interest as refuges. Some communities attempt to live in domed biomes on the Antarctic Peninsula, leveraging the cooler climate and abundant marine life, despite the logistic difficulties. The collapse of industrial emissions has a small silver lining for climate. By 2070, atmospheric CO2 is finally plateaued, possibly even dipped slightly as the oceans and regrowing forests draw down carbon. But this comes at the cost of global society collapse and mass mortality. In essence, the Earth system is reset itself in part by a brutal reduction of human impact, while locking in a radioactive legacy. The climate remains warmer and more volatile than the Holocene average, but without continuous fossil fuel burning, it may avoid worst-case 22nd century projections. Nevertheless, sea levels by 2070 are higher. Many coastal former cities are now tidal marshes littered with ruins, and superstorms will occur, though fewer targets remain to be damaged. Yeah, it's the storm surges that make most of the damage as sea levels rise. A couple of inches, a few inches, a foot. You don't think that's, but when the storm surge comes, forget it. Okay, that was it. That was the end. That was pretty long. Maybe I won't do the rest. But what I was going to cover, I'll do next time. I will cover how the pressures from the environment, the habitat, bring about changes throughout generations so that the species can adapt. So, from our very beginnings, we have experienced pressure from our environment, and it takes hundreds of thousands of years, if not millions of years, to make bigger genetic adaptations. What we have done, I've been saying all along that if we hadn't made nuclear power plants and nuclear bombs, more people could have survived climate change. It wouldn't have been quite as horrendous. It would have been difficult, and people would have died, and we would lose our infrastructure, definitely. But this, why would we have done this? You drag up out of the ground something that's so deadly. And what? To make money? They want to say so they can give us electricity so we can do stuff. Really? Well, the other stuff we dug up and pumped up was bad enough. It makes me sick to my stomach when I think of this. Now, it might not happen as fast as this article says, but it's going to happen. Maybe, as it starts a little slower, when they have, I don't know, 5, 10 meltdowns around the world, they'll get smart and start shutting down as many as they can everywhere. Maybe it'll only take like 5, 3 to 5 to melt down and have problems, and they'll start shutting them down immediately and decommissioning them, but it takes a long time. Maybe they'll start making cement domes over them before they even melt down. I don't know if they can do that. But something has to be done about this, or this is what we're going to experience. Like I said, if it happens a little slower, it gives us a chance to get ahead of it a little. But this is what we're looking at. So, there's that. Thank you for listening to Astrologer Climate Witness. How does this relate to astrology? Like I said in the beginning, Aquarius symbolizes man. We're innovators. That's what we are. Something about that brain that we have, that front part, anything in this world can be negative or positive. And we let us get carried away, flying too close to the sun. Melt your wings. Bye.